All right, welcome back to Applications of Calculus 2. Today we are going to talk about sequences and series. Sequences not so much, but we're going to talk a little bit about series. Okay, now this series section, if you ask other people who have taken calculus and they talk about series, they will usually have some terrible tales to tell you because it can be kind of a difficult thing. For our class, we don't have to deal with all of the stuff that people learn about series because we don't actually learn a lot of test of convergence. We only learn one series really well, two series really well, but one really well, and it's really easy to tell if it converges or diverges. Okay. And when we talk about diverges, we're talking about, okay, so let me start over a little bit. A sequence is just a list of numbers. Okay, so sequence it's usually there's some order to it, there's some method to it, but this is just a list of numbers. Okay. Let's see. I have a couple of good series here. One, one half, one third, one fourth, one fifth. I think you can sense a pattern going on here. One six, just in case you didn't. But the idea is you should be able to sense a pattern here and to say, okay, this is 1 over n. This thing has a name. It's called the harmonic series. Okay? Or harmonic sequence, rather, because we're not doing a series just yet. So it's a harmonic sequence. Okay. So when we add things up, it turns into a series. So if I say 1 plus 1 half plus 1 third plus 1 fourth plus 1 fifth plus 1 sixth plus dot dot dot, this is called the harmonic series. See, the difference is now we're adding them rather than just listing them. So that's like a big thing that we have to watch out for. So that's how you pretty much deal with a series versus a sequence. The sequence is just a list of numbers. The series is when we specifically add them up. Okay, and that's all there really is to that. There's two kinds of series that we generally talk about in calculus. The first one is called an arithmetic series. Okay, arithmetic, yeah, spelling that out. And pretty much what we're looking for is a series kind of like I'm going to go from 35 to 32 to 29 to 26, dot, 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 all the way down to 5. And we know it's an arithmetic series because there's going to be a common difference between each of the two values. So if I go ahead and say we want our second value minus our first value, so 32 minus 35, we get negative 3. If I'm going to do 29 minus 33 rather, or 32 rather, 29 minus 32, okay, again, there's a common difference of minus 3. So any two numbers you pick, the way that you get to the next one is you just subtract 3 from it. It could add a number or subtract a number. So if you have a common difference between any two values where you're adding or subtracting the same thing over and over and over again, that is an arithmetic sequence or series rather. We're adding or subtracting something. We're adding something. We add a negative number, but that's how we go ahead and figure that out. If you wanted to go ahead and add this thing up, we'd have to go ahead and deal with it this way. So we'd say there's 35, 33. Let me go ahead and do it that way. 32, 29. Let's see, 26. I wrote these down. Let's double check here. 26. Did I write these things down? I sure I did. Okay, there we go. I mean, I'm only subtracting 3. It's not that big of a deal, but 23, um, 20, 17, 14, 11, and then subtracting 3, we get 8 and 5. Okay, and I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these things to go all the way through. So how we're going to go through and deal with this. Okay, Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what I'm going to do is say that this is going to add up to something. I don't really know what that something's going to be yet, but what we're going to do is we're going to go to the other side here, and we're going to say here's 5. Yeah. Did I start at 35? Did I do this right? Yeah. So we have 5 of us sitting here. Minus, get rid of this. That's not here. 35 minus 3 is 32. So we have 11 of these things. It's like I knew something felt off. So here we go. So 35, 32, etc. I don't know why 33 was sitting there. But we have 5, and then the next value up would be 8. Add 3, we get 11. Add 3, we get 14. Add 3, we get 17. Add 3, we get 20. I'm not keeping these I'm not keeping a very good tally of keeping these guys in very much order, but we'll say dot, dot, dot till we get to 35 at the end here. The idea here is that each of these, 35 plus 5 is 40, 32 plus 8 is 40, 29 plus 11 is 40, 26 plus 14 is 40, dot, dot, dot. And we're going to say, okay, how many of these are there? And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of these things. So I have 11 sums of 40. And what we did is we just added these two things up. In the first case, we counted them from lowest to highest. In the second one, we counted from highest to lowest. But what we're going to get is this is equal to, we have two sums that we added up. So this is going to be 2s. Okay. Now we're just going to divide by 2, and we get 11 times 20 divided by, or 40 divided by 2 is going to be 20. So we just get 11 times 20, and I think that's going to give us, that's 22 times 11. So I think we're going to be getting, yeah. Okay. So yeah, we're just going to be getting 220 for our values, and that's going to be what our sum would add up to. Okay. So that's how you would go through it and add up an arithmetic series. Okay, you just write it from descending, and then you write it ascending, you add them up, and you just divide, and that's going to be how you should get a sum for this stuff. Okay, so that's an arithmetic series. Okay, we don't do a lot of those in this class. I don't think you're ever going to have a homework problem where you're going to have to do this, but if you do, that's kind of the way you want to sort this thing out. The other kind of series that we deal with is something called a geometric series. Okay. Okay. And what's different between an arithmetic series and a geometric series is that you have a common ratio between the two of them. Okay. So we're going to go ahead and do that. So I might have a 1, 2/3, 4/9, add, plus, and all I'm doing is pretty much multiplying this thing by 2/3 every time I go about this. So we have 8/27. We're going to say 8 times 2 is going to be 16. 27 divided times 27 times 3 is going to give me an 81, and then so forth as far as we go with this. Okay, so that's how you would write down a geometric series. Okay, in order to figure out the sum of a geometric series, I'm going to go ahead and write it down this way. I'm going to say, well, we're going to say 1. No, we're not going to say 1. We're going to say A times AR. So we have A plus AR plus AR squared plus AR cubed plus dot, 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 AR to the n minus 1. Almost the last one. Okay, and that's equal to something that we're going to add all of this stuff up. And then the next thing I'm going to do is say, well, I'm going to take this series, I'm going to multiply everything in this series by R. So we're going to say this is AR plus AR squared plus AR cubed plus dot, 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 the AR n minus 1. When I multiply this by R, we end up with an A to the AR to the n. Okay, because we multiplied this thing by R, that's going to increase the exponent by 1 here. Okay, and then what I want to do here is I want to say RS or S minus RS. We're going to say S minus RS. So I'm going to take S minus the RS. So I'm taking this piece minus, I'm taking this line minus the line below it. So we're going to get the ARs are going to cancel because they're just going to shift over one and they're going to cancel and they're going to cancel and they're going to cancel and they're all going to cancel except for this very last one. So we're going to say this is going to be, we have S minus A to the R, AR to the N rather. Now look what we have here. So what I'm going to do is I'm going to go ahead and factor out an S here and say this is 1 minus R equals A, and I factored that out, and this is going to be 1 minus R to the N. And then we go ahead and divide by 1 minus R. Okay, so my S, right, we divided by 1 minus R. So we have S is equal to 1 minus R to the N over 1 minus R. So when you have a finite series, this is what you would do with it. Okay, finite series meaning like, hey, it's going to go on for 7 times, it's going to go on for 8 times, etc. What we're going to have here. So we would go through and deal with it this way, where we would know what the 8th, 9th, 10th, 23rd, whatever power that they want to go to. What happens when this is an infinite series? As n goes off to infinity. Okay, so this is an infinite series. This n goes off to infinity. So what I'm going to ask us is, we've got Rn as n is going off to infinity. And this R, we're going to say R is somewhere between -1 and +1. It's a fraction, like a half or third, 5/4, 4/5, etc. Okay, it's some kind of a fraction, but I want it to be between -1 and +1. So at that point, what's happening to this R? Well, you've got a number here that is a fraction, raising it to a bigger and bigger and bigger power. What happens when I'll go ahead and show us, like what happens when we raise a number that's smaller than 1, it's between -1 and +1, to some kind of a power, and I'll show us what happens with this. We could say documents. Okay, I want to go down here to my calculator just so I kind of see what's going on here. Okay. Again, we're not using any part of the fancy calculator, so you can do this by yourself with any calculator that you have. Okay, but if I go ahead and take a number that's smaller than 1, right? If I want 4/5, that's a number smaller than 1, so equals, and then we raise it to some large power. So what if I want to raise this to the 8th power? Am I going to get a bigger number or a smaller number? I got, we started with 0.8. I only raised it to the 8th power. I'm 0.6, 0.67, 1.67. If I take this 0.8 and say raise it to the 20th power, okay, because we're taking this n, a limit as n goes off to infinity. So 20 is a pretty big number, 20 small number rather, compared to infinity. But I got a smaller number than we did before. So we were at 0.16, now I'm at 0.011. If I take this 0.8 and raise it to say the 100th power, right? Because now we're getting there. Say that, and it's 2.037 times 10 to the -10. There's 10 zeros before this. So every time I'm going to be taking this to a bigger and bigger and bigger power, this R to the N, the limit for this, is actually going to go to 0. Okay, so we can go ahead and deal with it that way. All right, so this piece here, as n gets bigger and bigger and bigger, and as off to infinity, it's going to get really big. This term, R to the N, is going to go to 0. So the whole point I'm trying to make on here is that my S, my sum of my geometric series, is going to be a 1 over 1 minus R, provided that R, the absolute value of R, is less than 1, or R is somewhere between -1 and +1. But the closer it gets to 1, the longer this is going to take for it to converge. Okay. Converge and diverge, those are words that math people made up. Converge just means it settles on a particular point. Okay, so the value settles somewhere. Okay, it comes down and settles to a spot. Diverge just means it doesn't settle. Okay. It doesn't mean it goes off to infinity. It doesn't mean anything. It just means it doesn't settle. So there's a very famous series that looks like 1 minus 1 plus 1 minus 1 plus 1 minus 1 dot 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 dot. If I pull the values this way, I end up getting 0 and 0 and 0 and 0. But it goes between 1 and 0 forever and ever and ever and ever. So if I graphed this thing and I started adding things up, it would be at 1, then at 0, then at 1, then at 0, then at 1, then at 0, then at 1, then at 0, forever and ever and ever. It never settles on a particular value. So this, we wouldn't say it converged. I mean, it's 0 a lot of times, great. It's 1 a lot of times, but it's not settling toward either one of those values. Every time you add an additional value, additional term here, it's going to ping pong back and forth between 0 and 1. So we would say this diverges not because it's going off to infinity, because it's not. It's either 0 or it's 1, right? But because it never settles on any particular value. Okay, so be careful about using the word diverge. It just means it doesn't settle. So when we use diverge, it just means it could be this kind of situation. It could go off to infinity. I don't really know, but it's got to do one of those two things. But it's not necessarily saying it's going to go off to infinity. It just means it doesn't settle on any particular value. All right, so try to remember that when we're using these terms. And converge just means it settles on a particular value. Diverge just means it doesn't settle on that value. It doesn't settle on any value. Okay, so that's the idea for this thing. So we could sum up an infinite geometric series. And again, we know that we're going off to infinity. We take the limit. R to the n is going to be 0. So we end up with 1 minus, or 1 rather, 1 over 1 minus r, provided my r is a small number. Okay? And that's how you sort out a geometric series. Uh, so about time to do an example and see what's going to be happening with this thing. Let's see if I can come up with a nice example for us. I said a nice example, not this horrible thing. Okay, so if we're going to do something like I've got 1 plus 2/3 plus, and I'm going to go ahead and multiply that by 4/9 plus 8/27 plus dot dot dot. And we're just going to go off for infinity. So I would write it as a sum of 2/3 to the r, all right, or 2/3 to the k, we'll say it that way, as k goes from 0 off to infinity. Okay, be careful about where we start. I think we start with k equals 0 with all these pieces. So if I plug in a 0, I get 2/3 raised to the 0 power. Oh, that's 1. So we can go ahead and start with what this is going to be. So this is going to tell me that my sum is going to be 1 over 1 minus whatever my r is. This is going to be 2/3. So we have to figure this out. So we have 1 over, I'm going to say that 1 is a fancy way to write 3/3. 3/3 minus 2/3. So we have 1 over 3/3 minus 2/3 is 1/3. So I've got 1 divided by 1/3. And if you remember how that works, we invert and multiply. So we say this is 1 times 3 over 1. So I would get my answer here to be 3. Okay, so that's what we do with geometric series, is we check, hey, is the r value between -1 and +1? If so, then this thing is going to converge, and it's going to converge to a value that we can go ahead and figure out. If we're going to get a bigger and bigger and bigger number, well, then it goes off to infinity, and it doesn't converge, it diverges. Okay, it doesn't settle. So I'm sure we can come up with values that say don't go off to infinity, but just don't actually end up getting somewhere. That would kind of be something like this. We would do something like, we could do like a 3/2. So we could say 3/2. We could say 1. Let's go with, we'll say, oh, I don't want to do plus. We could do like, we could do a minus, multiply this by 3/2. So that's going to be 9/4 plus multiply by 3/27 minus dot dot dot. So because the r value that I'm dealing with, I'm multiplying it by 3/2, that's not going to converge because one of the things we need for convergence is we need that R, the absolute value of that R, to be less than 1. Or alternatively, R has got to be between -1 and +1. Okay, so that's kind of what we're doing with that. And that's kind of the test that you're using to see whether or not if your geometric series converges. And if so, what does it converge to? Okay, and that's pretty much what we're trying to do with this stuff. All right, let's see what we have next here. I have anything left. That's my harmonic series. That's that piece there. Here, there, here, there. So I showed us how to go ahead and calculate that, and now that's where I'm at. All right. No, go away. I don't want this. Okay, I don't know. All right. We can go ahead and figure out the sum of a lot of geometric series. One of my favorite ones to ask is when k is equal to 0 to infinity. So we're just going to, this is a capital sigma. So the way I write my capital sigmas is like a backwards E kind of an idea with two little serifs on it. But if I say we're going to check the E over pi raised to the k power, okay? So first off, is E over pi, is this a number between -1 and +1? Well, we can always check, okay? So there's nothing wrong with getting a calculator out and checking, but let's just really quick go ahead and look at 2.71 divided by 3.14. I think we don't need to have the entire infinite series out to know that this is approximately 2/3, but it's going to be less than 1 here, okay? So that's what we have for this. If I'm going to go ahead and add this thing up, we're going to get 1 divided by 1 minus r, right? That's the formula we have for a convergent geometric series. And how do I know it converges? Is because my r is between -1 and +1. So we have 1 over, this is 1 minus e over pi. So I think, okay, that looks like a delightful fraction to have to deal with. Don't convert it to a decimal. We're just going to say this is pi over pi, right? That's a fancy way to write 1 minus e over pi, all right? So this is going to be 1 over pi minus e divided by pi, because that's how fractions work. So what we have to do is we have to figure this thing out. So I have 1 divided by pi minus e divided by pi. Well, how do we deal with inverted? We dealt with division of a fraction. We say, oh, well, that's just going to be invert and multiply. So that's going to be 1 times pi divided by pi minus e. And I'm sure this is a delightful number. So the value for this series is just pi divided by pi minus e. And we would say, okay, well done there. That is our value for this convergent sum. Okay, and that's what it converges to. So we can go ahead and deal with that. So there's a lot of problems like this that we are going to have in our books. I'll show you another one that I think is a particularly good one. What if we do something like we have the sum of k equals 0 to infinity, and I'm going to say we have 2 to the k plus 3 to the k over 4 to the k. All right, I think this is a fun problem. So what we're going to do is we're going to divide this out. We're going to say this is 2 to the k over 4 to the k plus 3 to the k over 4 to the k, because fractions will work like this. We can divide out the numerators over the denominator, right? If we have numerators added up, it's quite all right for us to do that. So we'll say, oh, wait a minute. This is a geometric series, and we can simplify this down a little bit. This is 2/4 raised to the k plus 3/4 raised to the k. So what happens here is this 2/4 raised to the k, this turns into a 1/2 raised to the k plus 3/4 raised to the k. Now, each of these series will converge because this 1/2 is less than 1, this 3/4 is less than 1. So I'm not trying to do them both at the same time. We'll separate these fractions out. So at this point, we're going to say this is 1 minus, or 1 divided by, rather. Okay, let's head. I want to erase. So there we go. Back to this. Draw. Okay. So we're going to say 1 over 1 minus 1 over 2, right? And that's one convergent sum. And then plus, and I've got 1 over 1 minus 3 over 4. Okay, that's my other convergent sum. So here we have 1 divided by 1 minus a half is 1 half plus, and then we have 1 divided by 1 minus 3/4. So that's 4/4 minus 3/4. Because the fifth way to write 1 is 4/4. So we have 1 over 3/4. Okay, and that's what we converge to. So here we have 1 divided by 1 half, which is 2, plus here we have 1 divided by, let's go ahead, 1 divided by 3/4, which is 4/3, of course. Okay, just invert and multiply. So we've got a convergent series over here that converges to a value of 2. We've got a convergent series over on the right part, and that converges to a series of 1 of 4/3. Now we can just add these pieces up. So we would say, okay, this is going to be 1 half plus 4/3. Okay, and we've already dealt with the series. We've already know it's converging. This is just what we have. So we go ahead and get common denominators at this point and just add up your 1 half plus your 4/3. I'm going to cheat. I'm going to say this is going to be 1 half. So we have, let's see, I'm going to say it this way. We have 1, where is my math button? Fraction 1 half plus, and I've got 4 fraction button. Where'd my math button go? Shoot, now completely lost it. Let's see. I just had it. No, no. There it is. Oh, so fraction 4/3. Okay, so that's how we do that. Add those guys together. Syntax beautiful. Uh, we'll do it the slower way. We'll just say, there's a slower way. Yes, there's a slower way. We'll say 1 half plus 4/3. Okay, 1.833333. I love this part of it where I go back to math and I do fraction. And I think we can go ahead and turn this back into a fraction and get a value of 11/6. Okay, you guys might have an ABC button somewhere in there. It does the same thing. Okay, so you could deal with the fractions rather than the decimals. But this whole thing is just going to be 11/6. That's what this sum would converge to, and this was what it would add up to. So that's kind of what you're looking at doing for this stuff. Okay. I think I'm going to call it as a video here. We'll pick up tomorrow and we'll do some more. But this may get you started on your series chapters. So go ahead and start working on that. These aren't too bad. They pretty much want you to list out the first five values of each of the series, and we'll show you a little bit how to do that. So thank you for watching the video and take care.